BSides DC 2017 videos are brought to you by Threat Quotient, introducing the industry's first threat intelligence platform designed to enable threat operations and management, and Data Tribe, a new kind of startup studio co-building the next generation of commercial cybersecurity, analytics, and big data product companies.
All right, thank you guys so much for coming. My name is Sean McCullough. First of all, I want to say you guys had a lot of other opportunities for things to do today with the CTFs and the happy hours and stuff like that going on. So I really do appreciate it that you're here today for the talk. On the pamphlets, there were two people supposed to be talking. My buddy Mike actually is in Italy right now on vacation, so he's a giant jerk. He's going to be watching this later, so I want him to know he's a jerk for just not showing up. But he told me beforehand. It wasn't like I just showed up today. First of all, I want to thank the AV guys. I caused some trouble, wanted to use the mic, and so I want to thank you guys so much. They've been working really hard all week with all the other volunteers. So if you guys, just to give them a round of applause, because they're doing such a great job. I want to thank you so much. My name is Sean McCullough, and I do work at the National Security Agency. I don't know if you've ever heard of it. Yeah, I know, it sucks a little bit. But this is actually a talk about what I'm doing in my day job, part of my research. So this is a National Security Agency project and everything. They looked at it and approved it and said, yeah, let's go and talk about it. I'm super excited to be able to come here and talk to you guys about it today. I promise you I'm not going to go over. I understand I'm the last one. There's a happy hour. I'm between you and happy hour. So I promise you I will not go over. I'm going to ask you guys, when I'm about 5 minutes from the talk, if you could just hold a finger and let me know. All right. Let me clarify which finger. Let's go with thumb. Yeah, I don't want, flick me off and then I'll be like, oh my God, why are you so pissed at me? My name is Sean McCullough. I've been 18 years at the National Security Agency. I spent the first half of my career in what's called signals intelligence. That's the kind of stuff that you see on TV dramatized in the movies where, the people are in the van and they're like, hey, turn the satellite on. And all of a sudden the satellite shows up and looks through the car, X-ray visions. That is all 100% true. That's exactly what it's like. No, it's not. That is one half of what we do. The other part of my career, the second half, has been in information assurance. We are responsible for helping provide security for some of the nation's most critical infrastructure, especially communications for the military. And one of the ways that we do that is through something called red teams, blue team, and hunt. A few years ago when I used to do talks, I would have to explain what red teams, blue teams, or hunts. But how many of you all have a general idea of blue team, red team, hunt teams? You've seen them in talks. Yeah. So, we've been doing that for, I don't know, over a decade. I don't know how long those teams have been around. And I love seeing those concepts coming out into commercial world and people taking advantage of it, learning and understanding, and changing it to fit their model. It's really cool to see that. I was lucky enough at one point in my career to be the technical director for the blue team, red team, and hunt teams. And technical directors like, I don't know, like a strategist or something. I don't know, went to a lot of meetings. But one of my jobs was to try and figure out, do we have the right tools in place to do the missions? Because we would basically write our own tools. It was pretty cool we could do that. And as a software developer, I was usually called on to kind of help figure out, do we have the right things in place? And my boss would come to me and would say, hey, over the last month in our hunt and blue team operations, what new things have we been able to do? And I'd be like, oh, we wrote 2 new analytics. That was the answer. Like, is that good? Should we have done 5 analytics? Were they the right analytics? What are we not doing that we should be doing? I really had no good answer for those questions. And then, the boss goes away is kind of sad. So I thought about it for a while, and I said, there's got to be something better for us to figure out where we should be and where we're going to go in terms of being able to try and find bad guys that are operating on networks. So I got lucky enough. I got to take basically a 3-year sabbatical. And during that time, I went out and I basically researched what companies, organizations, government organizations, research are doing in advancing the technology of intrusion detection. So I looked at machine learning, I looked at behavioral analytics, statistical, heuristical, threw all that kind of stuff at it. And I kind of went into it thinking I was going to find something that was going to be so much better that it fixes everything we're doing now. I was naive. I thought I was going to find something. And I did not find it. I found a lot of really cool stuff. I saw a lot of really new things that were actually that were pushing the envelope. but I still wasn't finding the ways to, how do I know we're doing the right thing? How do I know what we aren't doing correctly? That was the biggest question. We can kind of figure out what we're looking for, but I don't know what we should be looking for next. And then I happened upon some research that MITRE was doing called the MITRE attack model. And I said, you know what? That's not what I was looking for, but this is perfect. So I spent the last 2 years of my career working with MITRE, understanding the MITRE attack model, and building tools, open source tools, for people to try and make use of the MITRE attack model. So today I'm going to go over what MITRE attack model is. I'm going to talk about the tools that we are building and giving away and hopefully getting some great feedback on. And then I'll tell you about what we're hoping to do in future and give you an idea of how we are able to could interact and get people to try and talk to us and tell us what they need in their environment and see what we're doing. Does that sound good? Does that sound like a good idea? All right, you guys ready? All right. Before we can look at the future, I always feel like we have to go look at the past. So I want to introduce you to a friend of mine. This guy is so cool. This is Carl. So Carl was alive back in the 1800s, and Carl was a doctor, and he was a botanist, really. And Carl is known, and he's thought of as the father of modern taxonomy. Taxonomy is the idea of how do you classify and order things so that scientists and other people can communicate about them. That's what Carl did. And he had a sweet hairstyle. It was really cool. So Carl was really good at kind of trying to identify every little aspect of everything that he was seeing, writing them down, categorizing, building. And what he did is he figured out a model for naming and categorizing every living thing, right? So you've heard about this in biology class. You probably have forgotten it. But this is how modern day everything that is living is categorized in this taxonomy. So this was very important. I mean, if you think about the previous slide where I had discussion, I'll put it back up so you can see, the limits of my language are the limits of my world. This idea that back in that time, scientists would come up with or would discover something new, a new plant, a new animal, and they had no really good way of sharing it. So we're going to use an example. So it's kind of a silly example, but I think this proves the point. So Nicholas and Mike are at a party with Carl here, right? So we're all at a party. We're at the happy hour with Carl. And Nicholas and Mike, two gentlemen, and they're like, Nicholas comes up, I discovered a new animal, right? This new animal, it flies, it has wings, it's black, it's got claws, it's a brand new animal, it's so cool. And Mike is like, hey, I saw the same animal. It's got wings, it's black, it flies, it's got claws. We must discover this name animal. And they've named the animal. So that scientists at the time, they would draw it and write it. The problem is, Nicholas discovered a crow and Mike discovered a bat. You know, they only had a small amount of ways to describe the characteristics, and it wasn't matching, and they weren't able to define it. So Carl figured out how to kind of create these layers of abstraction so that as you get lower and lower, you can identify the proper characteristics and be able to name something and then be able to share it with the rest of the community. So you've probably seen something like this, right? So there's a difference between Homo sapiens or humans and ostriches. They get down to a level. At a certain point, there's identification. There's a set of characteristics that makes them different, right? You look at the order. One's a primate. The other one is I don't know what that is. A bird. I don't know. I have no idea what that is. I should have picked something else. Aves. Sorry, that was a bad option there. But there's characteristics at this layer that says these are different things, and no matter what animal or plant or whatever is named, you can categorize it in these levels. All right. So that's the kind of history of taxonomy. How does this apply? Bats and crows. How does that apply to us? Let's fast forward. We're in the present day. We're at the happy hour, and Mike and Nicholas are having a conversation. But instead of Carl, they're talking to Ed Scotus, right? So they're having this conversation, and they want to describe to each other a threat or an attack or something that's going on inside their networks. We have the capability of describing some things in a taxonomy in a lexicon that we can understand. So you can talk about an IP address of the C2 node that we see beaconing out to. Right? We can describe that. If I say IP address, you probably can read it, understand what it is. Same thing with the domain name, right? There's a taxonomy there that we all understand. File hashes is another one. The problem with those things is they change very quickly. It's very cheap and easy for an attacker to change an IP address or a hash or a file or a domain, right? But there's an entire industry built around coming up with new IPs, domains, and hashes and sending them out. People buy these feeds, your antivirus, their monitoring system that you might have at your network, which do a really great job. I'm not saying they're not great, but they're identifying things that are known in a taxonomy that's easy to understand. You're able to automatically take advantage of it and block, and it's awesome, right? It does not help if you're trying to figure out what is the behavior that I should be looking for. What is the things that an attacker's doing that look different or I should be watching out for? So think about this. Let's assume that you all are the smartest analyst in your company that's supposed to be monitoring your network, right? The boss reads this new threat report, come up with by some company that's put it out, or a researcher, or someone's put it on Twitter. There's a ton of new stuff coming out on Twitter of new attack techniques. And they take that, and you're the smartest analyst, so they're going to give it to you, and they say, can you tell me if we are protected from this? And usually what you have to do, and we kind of know this because we went out and talked to over 100 different companies and government groups and individuals who have to do this kind of work, and this is kind of how they described it. They take that research, they reanalyze it, right? So every single person that's going to take advantage of this research reanalyzes the whole thing. And then they have to figure out what it means to them and their environment, analyze their environment, because usually it's really hard to tell. And then they write a report in an email and send it up to the boss at the end of the day. Entire day, they've analyzed it. It's in an email. That's the results. Or some of the really good ones, we're putting it in Excel, right? The InfoSec's toolbox is Excel, which is fine. It's great. It's documented. But it's not repeatable. It's really a waste. There's got to be something better. And so we saw the MITRE attack model, and we said, I think there's something new here that we can use to try and help bridge this gap between the taxonomy and the lexicon so we can describe more complex problems than IPs, domains, and hashes. And so here's the fancy slide. But the other problem is it's a lot of communication. Well, that was weird. All right. Okay. It's a lot about communication. How can you communicate between the net defenders, the professionals? We say professionals. We're thinking like the researchers, that come out of the research. These are people who are actually trying to figure out how to protect their own networks, or the boss, that has to figure out where to put the money to protect your network, right? These three groups are always having to figure out how to talk, and they don't have a common language or common lexicon. We think there's a better way. We are building a set of experiments to try and figure out if we're correct, and there is a better way. All right. MITRE, if you go to attack.mitre.org, this is what's on the page. Threat modeling methodology for various phases of the adversary life cycle and platforms that are known to be targeted by cyber threats. This is what MITRE puts on the page. I have a different spin on it. Now, I don't work for MITRE. Good friends with those guys. I love them. But I kind of have a different spin on it. So let me ask a question. This is mandatory fun time, just so I can understand where we're at. How many people in this room have seen this slide? Either you've gone to the webpage or you've been to a brief. Can you keep your hands up if you would, so I want to try something. All right. So, I don't know, half, maybe a little less than half. Of the people that have their hands raised, keep your hand up if you're actually using this in your environment somehow. A lot of hands in there. Some right in the back, there's a good group. All right, great. Oh, that's awesome. All right. So if you have never seen a MITRE attack, now you can raise your hand because we're going to go through it. I have a different spin. For those of you who've seen the brief, probably have a little bit something different about it. If you don't know if you like it and you're interested in it, but you're not using it in your environment, I'd love to talk to you. I'd like to hear what your needs are and how you think you could use this to put in your environment. But the MITRE attack model is a taxonomy for describing attacker behaviors. So this, on this page, for those of you who've seen it, this is actually, every one of these boxes is a description of an attacker behavior. This entire sheet is actually just post-exploitation on a Windows box. There is one of these pages that looks similar to this for mobile phones, Mac OS, Linux, enterprise services, and also something called pre-attack, which is like scanning and initial exploitation and all that kind of stuff. So you're thinking about the different layers. There's the description of behaviors. And then I have my domain, right? So kind of going back to that original lexicon. And then you have this idea that I'm going to group this by the things I care about for my particular interest. For this case, I like to use the Windows one because it's been around the longest and I know it the best. And then there's different layers. So I know you can't read it. It's fine. You can go on the page. It's a lot of data, but it's not meant to be read right now. But I want to just describe what you're looking at. This across the road, this blue, each of those is what's called a tactic. This is the thing the adversary wants to do, all right? I'm going to blow it up so you can see a little better. It's still not great, is it? You guys in the back, you can't really read it, right? Somebody, okay. I'll read to you. So this is, they want to gain persistence. Privilege escalation. They want to evade the defenses. Credential access, which is, I'm logged in as some user, but I want to be a better user. Discovery of what else is on the system or maybe in the network. Moving from one box to another. Gaining execution of my really cool malware. Collecting data of interest. Of course, you got exfiltrated out. Why else would you be on the box? And then command and control. So each of these blue things is what's called a tactic. This is the thing that the adversary wants to do on your computer. All right? Now, for each of those blue things, all the boxes down are all the techniques that have been documented or reported or out in news or research that some actor has done this before, and then they're cataloged or categorized under those blue headings, right? You guys follow me so far? I know you can't read it, but you kind of get I'm trying to give the map a little bit. I figure you can go back and look on it later, or look on your phones now if you want. You probably see it. So I'm going to dive into one of those and really kind of try to show you how this kind of walks through. So this is credential access. I love credential access because this is my best friend right here. I love credential dummies. This is Mimikatz, right? So if you go onto the webpage, tac.mitre.org, you click the Windows exploitation one. I think it's called Windows exploitation. You'll get that box I showed you before. You'll get this. And then you click on any one of these boxes right here, and you're going to get this, all right? You still can't read it. I realize that, but I'll walk you through what it is. So credential dumping, Mimikatz. Here's a very detailed description of exactly what it is and how come it works so well. They've identified an ID for it. They have a list of all of the platforms it works on, right? So it's been observed to be worked on. This is small on my screen, but like all the different Windows versions that it's been observed to work on. This is the privileges you need in order for this to work. So what do you have to have in order for this to work? Administrator and system level access, right? And then here's the person who wrote it. If you're familiar with KPEC, it maps back to the KPEC where it makes sense. It's another thing of describing like vulnerabilities and reactions. And then down here it gives you examples. These are actually the intrusion sets that have been recorded or reported to have used that particular technique. All right? We're going to keep going. This is where it starts getting really cool. This is where I love this. Here is a really good write-up and description of how you would mitigate this technique. Here's a really good description of how you might detect this technique. And then here is a whole bunch of, this is a research organization, MITRE, so they've really given, here's all the references. This is how we know what we wrote down is real, right? So I love this because you think about it. You have the volume, very cool. All right, so you have this behavior, right? So you have this detailed described behavior that has been documented and identified. Now you start putting some context around it. Here's the attackers that have used it before, which is interesting. It's probably not that useful for a lot of organizations, but if you're a big company in a vertical, you might want to know what my other buddies have been attacked with this model. Maybe I should go look at it, right? Here's your intrusion sets. Here is your mitigations. Here is your analytics or way you might block it or detect it. And then here's the platforms, right? That's a lot of information. What's great about it is they've done that for every single one of those blocks. So it has, not all of them are using as much detail as Mimikatz, because Mimikatz has a ton of reporting. But you've got a lot of every one of these blocks, and this is one of 5 graphs. So there's 500. So there's a lot of detailed information. It's that context around the description of the behaviors that I found most interesting. I felt like that's what we miss when we start talking about a particular technique when, over email or you read the report. There's a description of this technique, but where is the so what? How do I kind of gain that? I have to reanalyze it. This kind of lays it out for you. But it gets better. This is where it gets really cool. Not only do they have something called MITRE Tech, but MITRE has something called CAR, Cyber Analytic Repository. You'll notice these are acronyms that are also words. I don't know how they figure out to come up with these things. But the Cyber Analytic Repository is a list of analytics, really, is what they are, right? So it's this list of, this list of analytics. Here's like a name, and then there's a description of it right here. But here is actually the list of all of the attack techniques that each analytic relates to. So before we had the MITRE attack technique, and there was a description of how you would detect it. Here's an actual way in which you could implement that analytic in your environment or in a generic environment. Each one of these analytics has a description of what the analytic is. In this case, in your environment, you might have cmd.exe be fired, but you probably want to make sure that it's coming from Explorer or something else that's known, and it's not some weird unknown file, right? So that's the idea. Look for command.exe being run from a really weird binary. Here's a description of why this thing is actually something you might want to look for, and then here is the attack techniques that it relates to. So this actually maps back to it. So now we have some more fidelity in those analytics, right? You kind of start seeing this map created. But this is where I love getting cool. Here's pseudocode. This is a description of the actual analytic in a very generic sense. And then here is a data model of the data and the action that you need to collect. So in order to figure out if command.exe is being launched from something weird, I need to know when a process is created, when the exe is created, and who its dad is or mom is, right? So the parent. And that's all I need. And I've listed it right here, and they built a data model. They also have a listing of sensors and what sensors can pull up. And you start putting this in this back system, now I can start making decisions based off of this data if I enter at one time. So in case in point, I was having a conversation with them, and a new version of Sysmon had come out. I don't remember what version it was. And they were looking at, hey, they identified all the things that Sysmon collects. And they said, hey, out of all the analytics in CAR, what's your coverage with Sysmon? And they were able to use MediaWiki to actually pull that information up. And they could say, hey, 80% of all our analytics use Sysmon. That's probably a good thing to suggest for these analytics, right? You can start making actual defined decisions about your environment because you had the context around it. That was the idea. And that's for every one of these. And you can just add to the list. So we really liked MITRE attack. We thought it was very interesting. It's a little brighter on my screen. But we looked at it and we said, this is really cool, but how do you use it? That was kind of hard. A lot of people had their hands up, they had seen it, but they're not using it in the environment. Sometimes it's hard to figure out how to use something like that. So we decided to try and come up with a set of experiments to build tools, open source tools that are free to the community that takes a person through a workflow so that they can get answers about their environment they couldn't have before with this kind of information, that they might be able to make a decision about their environment so they can better protect it, or they can try and mitigate something they weren't doing before. That's the set of experiments. We have hypotheses. We try and find people that are interested in trying it out. We gain information from them about how they work in their environment, what would work for them, and then we build a set of tools for people to try out, and they tell us whether it works or not. It is really a set of experiments. I will tell you that what we're providing, if you want to take and you put in your environment, that's awesome. Tell us how it works and how you want to use it and how it might be changed, because that's constantly what we're trying to do. I'm not selling you a product, right? We are. It's a set of open source tools, and I'll kind of walk through. It's kind of not as interesting. I guess the main focus of what we're trying to do is take that context of MITRE attack as a framework with all of the related data. Somebody adds their own information about their own environment to their instantiation of it. And can they make a decision? That's the big thing that we're trying to ask. So the first experiment that I started creating was something called Unfetter Analytic. And that is the GitHub repo that you can go to. Just so you know, everything is on www.unfetter.io, so it's all right there. Unfetter Analytic was really this idea, let's take a core set of a database or web application or some other kind of tool. Let's make the relationships we all saw in the MITRE attack, so every one of those specific attack techniques, the adversaries or the threat actors that have used them, the tools that you might use to actually perpetuate that attack. This could be malware or something like that. The analytics, and then courses of action, or sometimes what we call mitigations. Create these relationships and then see if we can make decisions off of it. The first thing, MITRE Analytic, the whole idea was, can I quickly stand up something in an environment, run analytics through them, right? These CAR analytics that we saw on the previous page. Get an alert. But instead of just seeing this alert 25 high, that's usually, sometimes that's a lot of times what SOCs are seeing. But put the context of why that analytic is important. map that analytic to the attack pattern it's trying to attack, or the MITRE attack technique that it's trying to attack. And then from there, you can quickly look at maybe how I mitigate it, or other people that it's been reporting. Provide those kind of relationships to it. That was the experiment. That's what we wanted to first try out. So I basically built standard ELK stack. On the right-hand side here is actually the server. So built a basic ELK stack. On top of it, I'm running Apache Spark. And then we converted a whole bunch of the car analytics into PySpark to run the analytics. Implementation isn't as important, unless you're actually interested in going and play with it. But the idea was every one of those analytics, when they fire and they bring back the information from the MITRE attack model, and they describe it to you in the Kibana display, so you can kind of see it. So you get the so what. And that was the idea. We also set it up with it online. It's all in Docker. It's 2 commands to run the whole thing. And then we provide the NX logs to move the Windows error reports and the sysmon, not Windows error reports, I'm sorry, the Windows event logs and the sysmon logs over to the logstash with the analytics, and everything's tagged correctly, and it's all kind of done for you. The idea is for people to try it out and say, does this make sense for you? Would you use this in a SOC, this kind of thing? Not this particular one, but would you use this kind of thing? Does this help you? And that's the kind of questions we started asking people. And we got some good feedback, especially from people who are into analytic development. They were saying, hey, that's great. This is actually additional contacts that they could divide. But we went and talked to those 100 and something different organizations over a course of 7 weeks, I think is what we did. And they were like, this is interesting, but we actually don't know what we're running. Like, we heard that a lot. Like, we're not quite sure where our gaps are. We're not at this point of doing analytics. So, although experiment was interesting, it wasn't the most important problem. So, this is just a display which doesn't show up anyway, so it doesn't matter. So the next thing we did is we built a second set of experiments. This one's called Unfetter Discover. And this is a web application. And the web application, it's all open source, the same as the other one. Here's the GitHub repo right for it. The whole point of this one was to say, all right, you know something about your environment or what you care about, so put that into the system. And let me be clear. This system is something you download and run in your own environment. We're not hosting a version of it for anybody. So you run it in your environment, and you put in things that you care about in your environment, that you know about, and then you start seeing where your gaps are compared to the attacker techniques. That's the basic idea. So whereas before with Unfetter Analytic, we were really looking at that whole indicator and so what with the indicator, we started moving around the shield for the other parts of, I hit the wrong button, sorry. So the other parts for Unfetter Discover. We started trying to take advantage of these other relationships, all right? So if you're trying to figure out where your gaps are in your environment, you probably know what analytics you're running, or maybe you know what your mitigations are. Now, in our case, we use the top 20 critical controls. Is anybody familiar with the top 20 critical controls? A few of you. Okay, so we use those because they're free and available for anybody to go and look at. So we implemented those in the system, and we created relationships. And of course, we used the rest of the stuff from attack, the MITRE attack model. And so we built all that relationship into the backend system. And so our idea is, this is our hypothesis. Our hypothesis is that if you know about your mitigations that you have in place, and you can rate whether you're doing a really good job or a really bad job with them, you can see which MITRE attack technique you're at most at risk at. That's the hypothesis. And we believe that if you rate your stuff that you know, and you see your problems based off of what the attacker can do, and you can see what the history of that technique is, and how it's used, and how you detect it and mitigate it, and who's used it before, that will be more meaningful to maybe you or your leadership who has to figure out what to do next. That's our hypothesis. So we built Experiment around it. Experiment, and I kind of described it, but it's a little weird when I show people how it works, so I want to make sure that I do a good job here. So, and I'll say this. I probably won't do questions at the end of this because it's the last one and people, kind of probably want to go. But I'll stick around afterwards, and I'll probably hang out in the happy hour. So if you have any other questions, please come up and talk to me. I'd love to talk about this stuff, obviously. So I'd love to talk to you and hear your thoughts of where we can improve it or what you think works really well, too. We like to hear that kind of stuff. So if you are doing a pretty good job of patching your software, right, then you're at less of a risk for exploitation, right? I mean, I think there can be a debate on exactly what what this weighting is. But if you're patching really well, then you're probably not getting hit by a lot of exploits. If you're doing a really bad job of patching, then that's your risky area, right? That is something you probably want to focus on. All right, we'll look at the converse of that. You are doing a really great job of monitoring your network security traffic. If you're monitoring your network security traffic at your boundary, you'll probably catch really weird remote desktop coming into your environment, right? Or you at least have the tools to do that. Maybe you're not looking at the right dashboards, but you at least have the ability, and that's probably a lower risk. That's the kind of idea. Does that make sense? Does that make sense? Is that confusing anybody right now? It's okay. There's really nobody? Okay. It confuses me sometimes when I would talk about it. So we're trying to figure out the best way to explain it because it gets a little weird when you start looking at it. So what we do is not rocket science on how to do this. It's not designed for somebody to plug in their environment, scrape a bunch of data, and get like the golden nugget of exactly what I need to do. You know, that golden piece of thing that says this is the most important problem. That's not the idea. We have to do a little bit of work. And the first thing we do is we actually go through and you do a survey. This is all of the analytics, I believe. Yeah, this shows all the analytics that are in the MITRE CAR, right? So you go through and you basically say whether you are not using that analytic at all. Or maybe it's logging but only on a local system and it's not being sent back to anywhere. You're centralized logging but there's no alerting off of it, so it's just collecting a bunch of data, right? Or you're alerting but there's a tons of false positives, so it's probably useless in your SOC environment anyways. Or yes, it's awesome, it works every time, right? So you kind of rate this. And you go through and you rate all your analytics. When you're done, we start showing you, not based off of the analytics I'm looking to make sure I don't fall off. You're not getting shown what analytics look like. You're actually getting shown which of the MITRE TAC techniques you're most at risk at. You know, before we looked at with the stars, you answer one question about one problem, you see the answers by the techniques. That's the idea. So to walk through, because it's unreadable, this is actually the blue boxes across the top of the MITRE TAC chain, right? So this is the groups. And we're only using Windows right now, the Windows exploitation ones. This is your overall risk. Green is good, red is bad. And then these are, if you hover over, you can kind of see a breakdown of your questions. If you click any one of these blue groups, you get a list of all the attack techniques, those white boxes going down the column, and you get the rating for those. This is all of the attack techniques that there are no analytics associated with. That's probably one place you would want to look, right? So it kind of start telling you not just what you did on your analytics, but the so what. That was the idea. You can click any one of these MITRE attack models, and now you get a deep dive of exactly what that MITRE attack technique described. We basically pull all the information. And then the answers all the answers to all the analytics. We do this for the mitigations, the top 20 critical controls. If you ever go look at the top 20 critical controls, each control has between 5 and 15 sub-controls. And we ask very detailed questions about, do you have a policy for this control? Have you implemented the control? Is the control automated? And is it reporting back? And there's like a 1 through 5 rating for each of those. So it takes a long time to fill out, but you get a much richer information about your infrastructure if you do that. And then we also do it for sensors. So it is kind of generic because we don't have any products in here except for like Sysmon or some free stuff. But you can create and add your own stuff, and you can say, I'm running this kind of sensor or this kind of detection system, and it's running on all my critical systems, and that thing detects this attack patterns. It'll understand that. It'll tell you what you're doing, how you're doing. The other thing we can do is we can start rolling up. Remember, we are very interested in trying to figure out how to take all this data, all this contextual information, and be able to share it between different groups, not just people in the same team. But now we're trying to figure out how do we take that and roll it up to the people who have money, right? Who are you're going to and asking for and say, we need help in this area, and they're like, show me why. So we're trying to figure out what's the best way to get you to show so that you can show why. So for each one of those boxes, and I'm not doing a demo. I thought about the demo. I tried it today, but when I was a new hire, I had this big demo for like the boss, like 3 levels up, and I had the system running, and I see her coming down the cubicle aisles, and I turn back, and my computer blue screen like right then. So I'm freaked out about demos. So I don't have the demo, but it does run on my laptop pretty well. But you can click each one of those assessments, however you ask questions, and you start getting roll-up information. Here's the top things you probably should look at because they're where you're the weakest. These are the alerts that tell you basically which of the attack things across the blue you should be most worried about. You're doing pretty good here. This one maybe you want to look at. We also rated the attack patterns based out of, and I say attack patterns, but the attack techniques, the MITRE attacks, in the white boxes. We rated them by how hard or easy they were for an attacker to use. And we kind of looked at it based off of some other people that were using this and how they did in their environment. But we also kind of looked at like if you have to be like super elite to do it, maybe at a company that's not the first thing you care about. But if it's in Metasploit, you probably should care about it because a lot of people can run it, right? So it allows you to kind of flip. You can actually determine what your threshold of pain you're looking at, and it adjusts everything. So you can kind of see what you care about for your environment. So that's the first set of experiments. This is for people who are trying to figure out and assess their own environment. We built another dashboard. This was another experiment. We had heard and we had talked to people that were interested in trying to figure out if I care about these intrusion sets because maybe they're attacking my industry or they've been reported to attack my industry, what are they doing? And what's similar and what's different? Like, if there's all these intrusion sets and they all do the same thing, maybe I should focus on that, right? That was the kind of idea. So we built a threat dashboard with all that data that MITRE attack provided. And remember, we are pulling almost all of this information from the MITRE attack thing. So this is, and MITRE attack open sourced all the data, and we're pulling their data, and that's how we built it. We expect that as people, if they take advantage of this, they're entering their own data for their own environment because it's going to be different for everybody's environment. Their care abouts will be different. But over here is actually a list of the intrusion sets that are in there. You can click up to 5, and you start seeing highlights of the attack techniques that they have been described using in the research that MITRE had. The colors don't kind of quite come out here, but you can start seeing overlaps too. So it'll actually tell you by multiple colors if all five of them use this particular technique. It'll highlight all that, so you can kind of look at it from one shot. But remember, what we care about is not so much what are they doing, but what do I need to do to stop it. So you can click a tab at the top, and you actually get a view of the mitigations you should probably put in place first, because it is most used, or these mitigations will block more of the attack patterns that were described before, right? So the idea is these 4 people I care about, these are the attack techniques they like the most. These are the mitigations that will stop those attack techniques. Does that make sense? Does that make sense? All right. So as I said, this was a set of experiments. We do this using something called the lean startup model. We're basically a really small startup inside of NSA, which is huge. So it's really weird, and it's government too. Like saying, oh, we're like trying to be a startup inside of government is really odd. Especially when you look at like how much approvals I had to get just to bring these slides here, And what we do is, unlike a lot of startups, which says, I have an idea, I'm going to go spend a year trying to build something, and then I'm going to come out and try and sell it. We actually try and do the opposite. We come up with an idea, usually based off of talking to other people, or because we have seen it before. Me and my partner, who is having a great vacation right now in Italy, we're both come from the blue team, red team, and hunt team. So we had seen this kind of stuff, these problems before inside of our customers. We kind of thought it would be really different. We thought the commercial world would be like a lot better, but that didn't be the case. They just had different scales of problems. So we decided to say, instead of trying to build something and then try and convince people that it's a good idea, we decided everything that we build is based off of people who said, I'm interested in this. This is how I want to use MITRE attack. A lot of the cases the people we talk to are doing it in an Excel spreadsheet, and at some point it becomes unwieldy. And so we start building, and every month we do a full deliverable to GitHub for people to try out and to demo. So it's constantly changing, it's constantly getting new features based off of the information we get from people who are interested in it. And then we go to them, we say, all right, try it out. And then we measure how effective it is for them. We ask them, it says, did you use this? Was it important? Did it give you a new insight you didn't have before? And if they say yes, then we say, great, we'll keep going. If they say no, we'll say, all right, maybe we will stop this feature. It doesn't help. Until we find somebody that works. Just like the Unfetter Analytic, which is the first thing I built. I love it so much. But we stopped it because we weren't finding the people who could take advantage of it. Love to restart that again. But we moved to this because we found this is where the people had the most problem that we talked to. Just about the product itself, I mentioned what was built for Unfetter Analytic, Elk Stack, Apache, all that. It's everything we have runs in Docker. We try to build it so you only need 2 commands, git clone, and then Docker compose up, basically builds the whole thing. It's really nice. We built the backend in something called Sticks. Is anybody familiar with Sticks? Can I just see those hands? Wow, a lot of people. That's pretty good. Are you using Sticks in your environment? Couple of some, oh, really good. All right, so we built everything in Sticks 2.0. I think we're not quite at the next version, but we needed to pick something. We're all JSON and REST, so we said, oh, Sticks 2.0 is great. It's all JSON and REST. But what this is a standard for communicating threat information between processes or groups that don't really know each other, right? That's the idea of it. So if someone is coming up with new, they're doing research and they're discovering new threat information, they can publish this Sticks data. Any other product that is Sticks compliant can receive it and add it to their system. So we built everything in Sticks. MITRE is actually publishing the attack matrix and all of the relationship stuff in Sticks. So when you bring it up, it goes and pulls it from their GitHub and loads everything, so it's kind of new every time you run it. I had this slide, it was a little bit old. I think we were the first open source product that actually used Sticks 2 to that capacity, to that level. I put one up because I'm not quite sure, but I didn't see anything else. I'm actually part of the Oasis group that oversees the Sticks, so I'm trying to always figure out what's the new thing that people are talking about and working on to make sure our product supports it. Because we want these Unfetter products to be able to communicate with each other and with repositories of people who are starting to build Sticks data so that as threat data is being created and published, this will bring it in and take advantage of it. So. Yeah, this is probably we'll skip that. It's not too much work. Just real quick on Sticks. This is all of the Sticks objects that we take advantage of. So attack patterns, campaigns, courses of action are like mitigations, indicators or analytics, same kind of thing. Identities is like, Frank created this new thing, so that Frank's ID is on it. That's all that is. The malware. I'll skip over here. Threat actors and intrusion sets, which there is a difference, and I don't understand the difference, so I'm not going to explain it. It's really confusing to me. And then reports and sensors. The other thing that we do is citing. So in the Unfetter Analytic, when alert fires and it says, this is interesting, and it brings up in Kibana, it will also send the data to a local version of Unfetter Discover, and you can kind of see it in your list. So we thought about, what if people take advantage of that in like a little bit higher level dashboard than the SOC is using to look at all the events? The way we do that is we actually created a REST interface for all of our objects. If you download this and run this, you can go to an API page which actually generates this really great detailed example of every single API. You can click any one of those and you'll actually show an example of how you would add it and delete that data, and then you can actually run it. So if you're doing this production, I would turn this off. But for development, for experiments, this actually works really nice. I will say that at an upcoming conference, there's a couple folks that are actually trying to figure out how to use this API in their environment. So the Unfetter is describing the data that they care about the most. And I think they're going to brief it at Wild West Hack and Fest. So I'm pretty excited to see what comes along with that. All right, so just kind of in summary, and a challenge. So if you have never seen MITRE ATT&CK, you have now, really quickly. I ask you, go take a look at it. I think it's a really great resource. Think about how you might be able to take advantage of that detailed information in your environment. If you have looked at it and you've been thinking about how you take advantage of it, I would love to get some input on how you think you would use it, the MITRE ATT&CK. I'm not selling you on Unfetter. This is an experiment to try new things. I would really love to see people who are building their own tools or companies go and grab this, say this is a great idea, and implement in their own product. That'd be great. This is MIT and government license. I think you can do whatever. I'm not a lawyer, so I don't want to say that on camera, but I think you can do whatever you want with it. Go read what MIT license means. But I would be happy for people to use it and let me know how it works. But we're also looking for people to provide detailed feedback about the product. Say if I have this environment, we have this problem, I need this answered. I have this question, I need it answered. This is the data I have. I would love to hear that kind of stuff because maybe we can put it into the product. A couple things that we are getting ready to start working on now. We are going to create a more detailed model for analytics and sensors so that when you create an analytic, you'll actually put in that pseudocode that we saw with the MITRE ATT&CK model. It will know the data model that you need to run that analytic. It will have the sensors, it will know the data model. It will start recommending which analytic you could use in your environment based off of the sensors you assessed before. That's cool. I'd love to see that work. I'd like to see that work and not be so cumbersome that no one's going to enter it. We're hoping to make it easy to enter the data. But that's one of the things we're doing. We're also doing some stuff to do text analysis so that you can feed it a report and it'll tell you which MITRE ATT&CK techniques were described in that report and the intrusion sets are described. So instead of that, remember that you guys are the smartest analysts and you're given that report and you have to figure out what's in it, we're going to try and provide some tools to help you figure that out on your own. That's called Unfetter Insight. And we got somebody that's playing around trying to figure that. It's an experiment, may not work. The other thing that we're working on is we're trying to create these unfettered systems so they talk to each other. So you can have a hosted system that has publicly available information that's being updated whenever. And then you can have your own privately hosted one that's only for your environment, and it can go out and it can pull that data. We probably will have that working, I hope to say by by January. I think it's probably have all that done. But being able to exchange that information. And we're also talking about, because we really care about that exchange of information. So the analytics that are put in here, you could share with other unfettered systems, or you can have a bunch of people logging in and entering analytics, and we're going to actually do a rating system in there so that you can say, yes, this analytic works for me, or no, it didn't work, and this is why, and you kind of crowdsource that. So that's another one of the things, because we have large groups of organizations that maybe don't work together, but they're all working together on analytics. We want to try and help those folks. We're also going to improve the threat dashboard so that you get better reporting out of it. So that's the other thing they're working on. That's what we're doing right now, so between now and in December. So we're always looking for new challenges for the new year, and so if you have some really great idea, we'd love to hear about it. I appreciate your time. Thank you so much. I know this is the last one, so thank you, BSides, for having me, and you guys have a great day. Thank you. Thank you.